cart starting here at point 1. And the way I asked in the problem, I said make that your reference level. So from this point, the reference level to point 2 is 10 meters. And then from the reference level to point 3 is 15 meters. Okay. So first we need to get the potential energy at this point. So PE is mgh. So it's 1,000 times 9.8 times 10, or 98,000 joules. Where did the car get those joules of potential energy when it got up there? Where did they come from? Exactly, right? As the car is going up, its kinetic energy is being converted to potential. And then it comes down. So now, if this again is our 0 mark, right? This is always where 0 joules of potential energy is. Because that's how we define the reference level. What is its potential energy at point 3? So now, at point 3, 2 is mgh. So again, it's 1,000 times 9.80. Now you make it negative there, because you're below your reference level. Now, that negative is not direction. It's saying that we now have a deficit of potential energy. So that's negative 147,000 joules. Right, so to go from this point down, you will have lost this much potential energy, and it will have become kinetic. Okay. And then just to get the change from going from 2 to 3 is just 3 minus 2. So you got negative 147,000 minus 98,000.
How come gravity doesn't change from positive to negative and vice versa?
I want to look at this real quick here. So let's say that we had a slide that looked like this. All right, and you are on the slide. Your mass is 10 kilograms, so that's pretty small. You're just a kid at this point. And the height of the slide is 10 meters from the hill to the bottom.
Huge slide.
Yeah, it's a big slide, right? So then you slide to the bottom. What is your speed at the bottom? Can we find that?
Yes.
Can.
Yeah.
All right. What is it? Don't need to know an angle. Do not need to. Right. That's the beauty of this energy idea. Right. Let's look at why. So it's a frictionless slide. That's very important here to say. We make this the reference level. What is the potential energy at the reference level? 0. So that means that above the reference level at this point, the potential energy is mgh. So that's 10 times 9.8 times 10, or 980 joules. Now, as you slide down the frictionless slide, where does your potential energy go? Into kinetic, right? So that by the time you reach the bottom, your kinetic energy is equal to the potential that you had, 980 joules. And we know the equation for kinetic is 1/2 mv squared. So now you put your mass in here, 10, and you solve for v. And so v is 14 meters per second. And there you have it. We got the speed now at the bottom of the slide. No angles, no forces, no anything. Okay? No accelerations or anything. Now what if I did this? What if I modified the slide a little bit? And I do this. What is the speed at the bottom? 14, right? It doesn't matter that we did this, because this part would have been gravity doing negative work, and then the part on the way down, again, would be positive work from gravity. And they cancel, right? So it's as if you just went from here to here, and it doesn't even matter what happened in this area, because they cancel each other. So you have the same speed. we could even make it crazier, right? We could let's do this. Obviously, this isn't realistic, but we could put a loop in there.
That looks like a fun song.
What the heck? We'll put another one here. Obviously, if there's no friction, this will work, right? And so there we go. By the time you get back down, you still got the same amount of kinetic energy, so your speed 14. So part A, let's see here. When the ball is at your shoulder, what is its gravitational potential energy? So when it's at this height, what is the potential energy relative to the floor, right? So that's simple. That's just PE, mgh. The ball has a mass of 7.30, 9.8, and that's 1.12. So that is 80.1 joules. So relative to the floor, when the ball's at 1.12, it's 80.1 joules. B, when the ball is at your shoulder, what is the potential energy relative to the storage rack? So relative to 0.61, what is potential energy? So that is still force applied to the ball, but now we only want this height. Right? So that's 1.12 minus 0.61, whatever that comes to. And there it is 36.5 joules. Okay, so from here to here, it gained 36.5 joules. And then part C asks, how much work did gravity do as you took it from here to here? Right? Gravity did negative 36.5, right? Because gravity would have been down while the force was up. So part C was negative 36.5 joules is what gravity did. So you could also do it with an equation. You would do the gravity, the work done by gravity is mg hi minus hf. So it's that. And then the initial height was 0.61. The final height was 1.12. And that's where you get your negative from there. So negative 36.5 joules. Now, we know that we need to have a certain amount of kinetic energy at the bottom in order to have the speed we want, right? And kinetic energy is 1/2 mv squared. And we know that it's going to get its kinetic energy from its potential energy, which is mgh. So this needs to equal this. So all we need to do is how much kinetic when it's moving at that speed. So really, mgh becomes the kinetic there. And we know we want it to be moving at 29.1. Masses cancel, that's why I didn't give it, because you don't need it. And now you solve for h, you get 43.2 meters.